Hey there, everyone. So this is just a sort of quick supplemental video because in Lab 4 we showed a very basic RC filter, which is acting as a low-pass filter, and I just wanted to give an example of one of the real-life applications of such a filter, um, because I've had a couple questions about it in a checkoff, and I just want to have a good, clear demonstration of how these things work. So, what I have here, this is just a basic AC signal. I've got generating a sine wave from here, and I'm reading the voltage right here, right? And so it's just a pretty boring AC signal. And it's also pretty clear. We can see exactly the voltage of this signal at any moment in time, right? Now, this is not always the case in real life. In fact, it's rarely the case. We often incur signal noise, which is just, random signals, random radiation from other electronics, or just present in the atmosphere, right? So this is really common for if we have a long wire of transmission, or if we're doing wireless transmission, so if we're using satellites, stuff like that. So I'm going to simulate signal noise with these two other voltage sources. And so there are two main kind of qualities about signal noise. Signal noise is typically high frequency and low amplitude. If you have a good, what's called a signal to noise ratio, this means that the frequency or the amplitude of the signal that you want to read is significantly greater than the amplitude of your noise signal, right? If you have a really low signal to noise ratio where, maybe 1 to 1, if your signal and the noise have the same amplitude, it's virtually impossible to separate them out and figure out what we actually want to look at. But if we have a good ratio, we can just end up with a noisy signal. So I've added here these two sources. What they are is they are high frequency, low amplitude sources, right? So they're just going to simulate our signal noise. Now if I run this circuit, you can see this is much less clear. We now have this really thick line. And so the reason for that, if we zoom in on one section, we can see it's super noisy. We've got all these random peaks in here. So I just zoomed in there. Let me zoom back all the way up. So this signal is really noisy, and it's kind of hard to tell what we're looking at, right? And so we kind of want to clean this up. And so what I talked about with a lot of people in checkoffs is how we can use a capacitor as a low-pass filter and remove this noise. So I've already got the capacitor out here. Let me just place it into the circuit. Okay. And so this capacitor, based off of where it is there, is going to work to remove the high frequency and remove the noise from our circuit. So now when we run this, we are able to again retain that really nice and clear wave, right? This is the same voltage from right here, and this looks almost like the wave that we saw at the beginning, right? Because what we are seeing, what we're able to do with this capacitor is just filtering out all of that noise. That whole high frequency signal coming from these guys is just all filtered straight to ground, and all we see is this much lower low frequency signal. So this is a very common usage, a very basic demonstration of how we can do noise filtering with a low pass filter. Great, let me know if you have any questions about this.